Alright, so let's take a look at number 3. Number 3 says the length of a rectangle is 1 meter less than twice the width. Anytime you have a problem involving a shape, I do encourage you to draw it, maybe a little bit better than I just did. But it says the length of a rectangle. Once we have a picture, it's easier to label the sides here. The length of a rectangle is 1 meter less than twice the width. So if we call the width x, then this would be 2x minus 1, 1 meter less than twice the width. If the area is 55 square meters, find the perimeter. The first thing we need to do is set up our equation. To find area, we take width times length, or length times width, however you want to write it. The area is 55 square meters, and this should look familiar. It's basically like those zero problems we were working on earlier. So we need to multiply in this x and subtract the 55. We need to get it set equal to 0 before we can factor. Now this is going to be a long trinomial, so you would take your 2 times your negative 55, and you get negative 110, and we're trying to get negative 1. And again, if you systematically do this, if you don't know the factors off the top of your head, what I mean by that is you take 110, you divide by 2. Is 2 and that number you get going to give you negative 1? Probably not. But if you work your way up, divide by 3, divide by 4, divide by 5, divide by 6, so on and so forth, eventually you're going to find the factors 10 and 11, which do differ by 1. Now we want negative 1, so we're going to make the 11 negative. And for those of you that do this method, it is my favorite method. I would encourage you to write it out, and we are going to pull out our GCF. Oops, x plus 5. Pull out the negative 11, which will again give us x plus 5, and then we need to write out our factors. 2x minus 11 and x plus 5. Now, our solutions here are going to be 11 halves and negative 5. Think back to the type of problem here. We used x to describe the width of a rectangle. Can the width of a rectangle be 11 halves? Sure, 11 halves is on a ruler. How about negative 5? Nope, negative 5 gets thrown out here. So x does equal 11 halves. And I'm sure you remember from geometry, once you get x equals, you have to make sure you're answering the question. We were asked to find the perimeter. The perimeter is 2 times the width plus 2 times the length. In this case, 2 times the x plus 2 times 2x minus 1. Let's plug in our value of x, 11 halves plus 2 times. I'm sure you see me using a lot of parentheses here, and then we're going to just simplify. So we have 11 halves times 2 is 11 plus 2 times 11 minus 1, which would be 10. So 11 plus 20 is 31 meters. That would be our final answer here, the perimeter of this particular rectangle. Again, if you need to catch up, pause the video at any time. Alright, the last one we're going to look at is a height problem. So we have used the formula h equals r times t minus 16t squared. Now, the r is your rate, t is time, and h is height. Okay, if you read this box here, the coefficient t squared changes. If you look here, in the equation that I gave you 16 here. That's when you're dealing with feet. If you switch units and deal with meters, that number is going to become 4.9. Now, for those of you that do recognize this, These numbers or coefficients are half of the gravitational coefficient. 32 feet is the gravitational coefficient. We use half of it, or 16. 9.8 is that same gravitational coefficient in meters. We used half of it for this particular formula. So we have a question. A batter hits a ball directly upward with a speed of 96 feet per second. How long is the ball in the air before being caught by the catcher? How high does the ball go? Now, if you have not already put one of these in your calculator, you will be able to see what that looks like right now. These particular problems graph as a parabola, so it's going to look something like this. It might not be at this particular point on your axes, but it is going to be a graph. Time is going to run along your x-axis, and height is going to lie on your y-axis. So it says here, how long is the ball in the air before being caught by the catcher? Well, here is where the ball would start, at height 0 times 0. Where do you catch a ball? You catch a ball when it comes back down. Now if you look, what's the y value of these 2 points? Hopefully you're saying y equals 0. Essentially, this first question wants us to find the zeros of our equation. So we have h equals our r, 96 feet per second, times t minus 16t squared. And again, we want to know where y equals 0, where the height equals 0. Now if we go back to our solving, this is set equal to 0. So all we need to do is factor. The only way to really factor this is using GCF. And I would make a factor tree if you do not know, or try it in your calculator. But 16 is the coefficient GCF, and they also share a t. So when you take 16 away from 96, you get 6 minus, we'd have a t left here. So our two solutions, 16t equals 0, t equals 0, and 6 minus t equals 0, t equals positive 6, should make sense for this graph. This point would be at 0, 0, and this second point would be at 6, 0. So how long is the ball in the air before being caught by the catcher? The question to letter A would be 6 seconds. Now for letter B, how high does the ball go? Well, the highest point on the graph would be right here at the top of your parabola. What do you think the time would be at that point? If you guessed it's exactly halfway in between, you would be correct. This point is going to occur after 3 seconds. So how do you figure out what that would be? Well, we have this handy dandy formula to plug it into. We know that time is 3 seconds. So all you need to do is substitute that in and calculate it out. So take a moment and calculate that out. I'm hoping you get 144. So what was the maximum height? The maximum height was 144 feet. At this point in time, I would like you to go see the sub and get your homework assignment. See you tomorrow.